All right, Sugar Babies, Ms. Deer back on the mic for one last video for us. Let's look at the region bounded by y equals 4x and y equals 2x squared. Here's 4x, here's 2x squared. These are going to intersect at 2, 8. So if I want to find the area in terms of x, my x values go from 0 to 2 of top minus bottom. If I want to find the area in terms of y, my y values go from 0 to 8 of right minus left. So rad y over 2 minus y over 4. Obviously, this is much more beautiful to actually evaluate. If I want to rotate around the y-axis, this is going to make like a tulip. It's going to be round on the outside and flat on the inside. You can see that I'm stacking my cross sections in the y direction, and they're hollow. So my volume is going to be pi r squared minus pi r squared. Now, is that visible? So my y values go from 0 to 8. My outer radius extends from the y-axis out to the curve, so from 0 to this. So rad y over 2. My inner radius goes from the y-axis to the line, so from 0 to y over 4. Now, if I rotate this around, let's do y equals -3. This is going to make like a funky lampshade or like a cone, a dog cone. So here's y equals -3. So it's going to come all the way around this way and have a hollow center. So you can see that these are going to get stacked in the x direction. So my volume is going to be pi r squared minus pi r squared. My x values go from 0 to 2. Now my outer radius is going to extend from the line all the way down to y equals -3. So from 4x minus -3. My inner radius is going to extend from the parabola down to -3. So 2x squared minus -3. And let's do one more here because we have space. Let's rotate this around y equals 10. So y equals 10 is up here. Again, we're not touching y equals 10, so it's definitely going to be hollow. It's going to go this way. And because I'm rotating around a horizontal line, it's going to get stacked in the x direction. So my volume is going to be pi r squared minus pi r squared in the x direction. My x values still will go from 0 to 2. Now, my outer radius, again, because we rotate everything relative to the axis we're rotating it around, if we're rotating it around y equals 10, my outer radius is going to extend from 10 down to the parabola. So 4 minus 2x squared. My inner radius is going to extend from 10 down to the line. Definitely not 4, sorry, 10 minus 2x squared. My inner radius is going to extend from 10 down to the line, so 10 minus 4x. All right, so just to practice some stacking on this same region. So I had 4x and 2x squared. So let's stack equilateral triangles perpendicular to the x-axis. So they're going to get stacked this way. Remember, so I need to stack them in the x direction. So my volume is going to get stacked in the x direction. My x values go from 0 to 2. So the area of a triangle is 1/2 of my base times my height. Well, my base is going to be the distance from the line down to the parabola. So the base is going to be 4x minus 2x squared. My height, again, in an equilateral triangle, is rad 3 over 2 times my base. So my volume ends up being the integral from 0 to 2 of rad 3 over 4 times 4x minus 2x squared. All right, and let's do one more because I have some space here. Let's rotate this region around. Let's do x equals 9. So x equals 9 is over here. Now I'm going to make a really big hollow shape. And you can see they're getting stacked in the y direction. So my volume is going to be pi r squared minus pi r squared in the y direction. Now, my y values go from 0 to 8. Now my outer radius is going to extend from the axis of rotation to the outermost curve. So it's going to extend from 9 to the line. So 9 minus 4x. My inner radius, again, relative to the axis of rotation, is going to extend from 9 to the parabola. So 9 minus 2x squared. So hopefully this gives you a good idea of volumes of rotation as well as some practice stacking and finding area in terms of x and y.